It's African prime. African time. It's about time. It's African. Listen, man, before I get shot or anything, man, you know what I'm saying? Rest in peace for the people go for coronavirus, man. Corona is a disaster in this world. It's an invisible enemy. I hate you, Corona, man. If something I hate so much in this world right now, it's this Corona, man. Hate you so much, man. Corona-19, COVID, man. I hate you, man. Let me get my glasses, man. I hate you, Corona, cause I can't even walk right now. You know what I'm saying? All the time, lock myself in my room alone like a crazy or something. Okay, cool. Let's go. Let's go. So, is the African prime, African warrior. It's about time. I'm a sub-Saharan native. Time to shine. We're getting distinction. Easy, man. Easy. Let's get started, man. So, first and foremost, we got a question. I'm Hamish, but a lot of people like to call me 25 bacteria. You know what I'm saying? You can check out my music too. You know what I'm saying? I got my music, but please don't start to check my music under the link below before you get done with this. I do music, by the way. Let's get started. So, this is hyperbolic function. You know what I'm saying? How do you know? You see, now I touch my face. I'm not supposed to touch my face. I hate this Corona, man. So, how do you know this hyperbolic function? Hyperbolic function, if you have something here, let's say this is k. K can be any number, like here k is -1 over x. It means you have anything of x and then plus whatever. Let's say this is anything, let's get q. And then let's say this is y equal. This is hyperbola. So hyperbola in that form, for example, if somebody give me y equal to 5 over x minus 3 plus 6 is hyperbola. You know what I'm saying? Because it's in that format. When x is under, means at the denominator, then it's hyperbola. And then when there's a number here, it's hyperbola. So for this case, you don't have any number, means it will plus 0. You know what I'm saying? So we don't have anything, means you plus or 0, even if it's not there. Okay? So this is hyperbola when x is at the denominator. And this we call it vertical asymptote. Anything at the denominator called vertical asymptote. And this is the horizontal asymptote. The number which is in here is horizontal asymptote. Okay? Cool. So, my intention, I want to start with this question, but no problem. I started already, so let me go for it. But let's go. So, I'll say, write down the domain of F. So, in my opinion, now let me check it. I want to explain to you so that you can understand. Next time, you understand however the question comes. So, whenever you draw hyperbola, let me take it to a nature of hyperbolic equation. Let's do all of it. Let's leave this at the end. Don't worry about this. I'm going to do this at the end so you clearly understand. So in hyperbola, this number here determine, before we do that, excuse me. Okay, let's assume this is xy plane, Cartesian plane. So before you do anything in hyperbola, you have to know the asymptotes. Asymptote, let me tell you this, asymptote is like fire. Do you want to touch the fire? No! So how are you going to know asymptote? You see the denominator, equal to 0. Like, if you want to get the asymptote, you have two asymptotes. Asymptote is where the graph will never touch those axes. So now, the first asymptote is this. Look, x, take the denominator equal to 0. So what is the denominator? X minus 1, x equal to 0. And then you take this over equal to 1. So this is going to give us vertical asymptote, VA. But I say vertical asymptote, asymptote. Make sure you show all this work in your exam. You say denominator of x equal to 0. But what is the denominator of x? The denominator of x equal to this one, which is x minus 1. Oh my god. My pen again. X minus 1 equal to 0. X minus 1 equal to 0. So you take over x equal to 1. Oh, so that's my vertical asymptote. It at x equal to 1. What is x equal to 1? Look. 1, 2. Let's assume it's here. So let me say here, yeah. So x equal to 1. That's why we call it vertical, because it's gonna go vertical at x equal to 1. So here, the graph will never going to touch these asymptotes. How are we going to get horizontal asymptote? So in our case, horizontal asymptote, this number which is in here. So since they didn't give us any number, we say plus 0 because it has to be in this format. So this is a horizontal asymptote. For this case, it was going to be 6. So I was going to come at 6. 1, 2, 3, 4, 5, 6. And that was going to draw what? Horizontal line. But for this case, we have 0. So horizontal asymptote is going to pass here. Let me use other color. So it's going to be here. On top, you can bold it on top of it. So this is y equal to 0. So this is horizontal asymptote and this is vertical asymptote. You know what I'm saying? So when you finish, before you draw your graph, you can know the nature of a graph. How? You look at this number here. If this number is negative, we have 4 quadrants. This is the first quadrant, this is second quadrant, third and fourth. How do you gonna look at your quadrant? Don't look at this xy, the normal that you always know. Like my mom told me, my grade 4 told me this is y and this x. No, like x-axis, y-axis. No, don't look at them. Your axis that you're dealing with right now is your asymptote. This is your new axis for hyperbolic. You know what I'm saying? So this is our asymptote. So now we go right now. You know what I'm saying? So we have asymptote. So now if this number is less than 0, if it's less than 0, your graph is going to lie here. You see here? Means somewhere here. But you at the second quadrant and fourth quadrant. I'm going to write here. If the k, so let's call it k. If its k is less than 0, mean your graph is going to lie, lies second and third always. It must be second and third quadrant. Okay, so if this k is greater than 0, so for this case here, we know it's going to lie here and here. But if, for example, like this case here, because this is k is greater than 0, means it's going to lie in the first and third of our quadrant. So if k greater than 0 means the graph, let's say f of x, but if it's g of x, you can say g of x, but we say f of x means our graph function lies, or you can say function graph lies on first and third quadrant. First and third quadrant. You know what I'm saying? So now, before you even start to draw, I know, oh, my graph is going to be here and there. And the nature of the graph always like this. Oh, my apologies, excuse me. It must be second and fourth. Oh, yeah. So now the problem is you don't know where it's going to cut. Is it going to cut here? Or it's going to be here? Or it's going to be there? Like how it's going to cut. We know it's going to lie here. So you assume like x, y, and plane is not there. Like you take, like you assume like this x is not, like you deal with the asymptote. Means vertical and horizontal. Means gonna, so now you want to know where it's going to cut. So to know to cut means you have to find x-intercept and y-intercept. You know what I'm saying? So let's say write down the asymptote. We got asymptote. What is the asymptote? Vertical asymptote. So I can write here vertical asymptote equal to 1. Vertical asymptote. Asymptote. I always like to say double S. It's just single S. Vertical asymptote. X equal to 1. And horizontal asymptote. Make sure you say horizontal. Don't say HA like me, right? I'm corrupted. Don't follow me. Horizontal asymptote. What is horizontal asymptote? This one equal to y, which equal to 0. We're done with the asymptote. So this is done. I'm going to count for the facial, right? Now we go. Sketch the graph showing clearly the intercepts. So that's what you're going to do right now. You know what I'm saying? You cannot draw a graph like clearly if you're not going to find the intercept. To get an intercept is easy. Now let's go. Let's start with the first intercept. If you get the x-intercept, we know y equal to 0 always. Whenever something cut at x, y equal to 0. Now let's go now. Okay, if you want to get x-intercept, y equal to 0. Remember, f of x means y. This is like a y. So if you want to get x-intercept, y equal to 0. So this is going to be 0 there. Equal to -1. X minus 1. But unfortunately, this is 0, so I can just ignore. So we want to get the value of x, which is going to give us the x-intercept. Okay, so now what I'm going to do, I'll say over 1 and then cross multiplication. Now 0 times anything. Oh, 0 times all this group, because we're going to say 0 times x minus 1, and the 1 times -1 equal to -1. 0 times something 0 equals to -1. So mathematical, you cannot say 0 equal to -1. That's not true. So it's not equal. So in other way, it seems like we don't have x-intercept. In other way, this graph is not going to cut at x for this case. So no x-intercept. I'll say no x-intercept. Oh. You know why? Because when this graph comes, it's not going to cut. We say intercept is like a fire, man. And this graph is not going to cut here, look. Because there's this intercept is like, say, you want to come here? Huh, you don't want to touch me because I'm intercept, I'm fire. That's why he want to come and cut at x, but I couldn't. He's not going to because of this asymptote. But if the asymptote was here, maybe just going to come and cut. Now, let's get what? Y-intercept. Y-intercept, now it's like the reverse of this. When y-intercept, x equal to 0. It's like the reverse. When y-intercept, x equal to 0. Okay, now let's go. So we're going to say y-intercept equal, oh, it's not good to draw there because I want to draw my graph here. My apology. So I'm going to say, okay, when y-intercept, because this is y equal to -1 over, what is the x? X equal to 0. We say when y-intercept, x equal to 0. Okay, so with -1, x equal to 0, and then plus 0. So, my God. got something here. 0 minus 1 means 0 minus 1 plus 0. I was just wondering how can that be possible. Equal to negative 1 divided, because this one be 0 minus negative 1, negative 1, negative equal to positive 1 plus 0 equal to positive 1. Oh, so y-intercept equal to positive 1. So you can say, oh, so my y-intercept we have means x equal to 0, but y equal to negative 1. So I'm going to take this stuff and plug in here. Oh, x equal to 0, but y equal to negative 1. Oh, x equal to 0. Let's say this is 0x, y equal to negative 1. Let's say somewhere here. So this graph is going to catch somewhere here. Oh, yeah. Oh, so the graph, the nature of the graph is going to be like this. That's all. Because no one I catch at x, you remember there's no x in the set. So it's going to be like this. It's like this. Because there's an intercept here. Excuse me. You know what I'm saying? It means here there's an intercept, so it's going to come. Let me draw like this. Let me draw well. So this is going to come all, and then cut here is going to come closer, but it's not going to touch the asymptote. Is going to go down all the way. And remember, since it's negative, it means it's going to lie on the third and the first quadrant of asymptote. It means it's going to come and lie here also. You know what I'm saying? You don't have to work it out anything. The moment you get to one side, you know, oh, it's negative. And when it's k is less than 0, which is negative, it's going to lie on the second. And what did I do? When k is less than 0, it's lying on second and fourth, man. I did wrong here, my apology. And fourth quadrant. My apology. Fourth quadrant. Means when it's negative, it's going to lie on the second and fourth quadrant of asymptote. Means what I did is wrong here. You know what I'm saying? Because for what I did, if this negative must lie here and there. So I made a mistake. So I want to check. How did I make mistake? Excuse me. Okay, so we check our question. We say, okay, if you want to get, what is that? We say, when x intercept to y equals to 0, y equals to 0. So y equals to 0, we cross 0. There's no x intercept. Okay, now we go for y-intercept. When y-intercept? When y-intercept? Oh, how did I get negative here, man? So we say, okay, so negative 1 and negative go positive. So this is positive. Why do I say negative? I'm wrong. This is positive. So this graph is wrong here, so I'm going to have to correct because the value of y is positive. And you see, I had a lot of contradiction here, you know what I'm saying? It didn't make sense. So y is 0, 1. 0, 1 means here, let's say x equal to 0, y equal to 1. So this is wrong also. Excuse me. So the graph is going to come like this. You know what I'm saying? Because we know since k is less than 0, so the graph is going to lie on the first and third quadrant. So it's going to come like, we know there's an asymptote here. It's going to come like it just goes straight, but it's not going to touch. And since you get this, we know it's going to come here also. By nature. You know what I'm saying? So first and third quadrant, and that's how you get it. You know what I'm saying? So this is how you draw for this case. Okay, now there's another question also. Let's go for the last one. So I'm going to erase this. I don't need this. You know what I'm saying? Let's erase, and then I'm going to show you something which they didn't ask you any question. But they always ask every day, all day. Every day, daily, without basis, okay? Okay, cool. Now we go. So now say for which value of x will also. Now, look, this is very easy. And then after this, I'm going to show you something which they always ask, but it's not right now. I don't see any question. Okay? For which value of x means the one, oh, x equal to what? For f of x critical to 0. So in other way, if you want to know which value of x, if I put it here, it's going to give you everything here bigger than 0 or 0, equal or greater than 0. Okay, so now I'm thinking, okay, so I got f of x here, and then I have a negative 1, and then I have a x minus 1. So I'm thinking, which number should I put here? It's going to give me everything here equal to 0, like it has to be equal or greater than 0. Okay, so now I'm thinking, okay, so what I want to do, if it's me, there's a lot of ways I can do. I can say, okay, so now look. First of all, I know this number should not be equal to 1. You know why? Because if this number here, look, if this is going to be equal to 1, it's going to be what? Look, it's going to be negative 1 over 1 minus 1, and this is going to be 0. And me is going to be negative 1 over 0, which is undefined. You don't want to have any day. Number divided by 0 is undefined, means it's like impossible. Okay? So by any means, you don't want this number to be 0. Okay, so and how is going to be 0 when this equal to 1 is going to give us 0. So first and foremost, you know, this x cannot be equal to 0. That's the first step you're going to say. So I'm going to say my condition first. This x should not be equal to, equal to 1. No, it's not supposed to be equal to 1. That's number 1. You know what I'm saying? Because if equal to 1, it's going to be negative 1 over 0 undefined. Okay, so that's not, it's not supposed to be like. So now, how am I going to make this stuff equal to 0 or greater, like the whole everything? Okay, I'm going to say this value here, it has to be, look, let me say greater than 1. Because if I say this number negative, let's say negative, okay, let's say x equal to negative 2, what's going to happen? Look, it's going to be negative 1 over negative 2, right? Negative 2 minus negative 1 is going to be negative 3, which is going to be positive number because it's going to be 1 over 3. And 1 over 3 is greater or equal to 0. Oh, it does work. So this number here must be less than negative 1. What happened? How if it's positive 1? Let's say positive 2. Because positive 1, I'm saying no. Let's say positive 2. Positive 2 is going to be a problem because look, it's going to be negative 1 over 2. 2 minus 1 equal to 1. And when you divide, it's going to give us a negative number. Means the whole function is going to be negative number. And we're not supposed to have a negative number. We say it could be 0, it's okay? Means everything can be either 0 or greater than 0. You know what I'm saying? So, so for that case, if I say 3, 3 is not going to work because it's going to be negative 1. Okay, 3 minus 1 is going to be 2. So it's going to be negative 1 over 2. And you see this number right there is less than 0. And it has to be either 0 or greater than 0. Oh, so for that case, this number here, it has to be less than negative 1. Sorted. So for us to have this stuff greater than 0, mean this number here, x, must be either, must be less than 1, negative 1. Not even equal. Because if it's equal to negative 1, if it's equal to negative, yeah, even negative 1 also, it does work. Less or equal to negative 1. Even if it's equal to negative 1, it's going to work. For example, look, negative 1, even 0 also is going to work. Excuse me. Less or equal to 0, my apologies. Even 0. Because if you put 0 here, look, 0. 0. What happens? It's going to be 0, and then here we're going to have what? Negative 1 over 0 minus 1. It's going to give us positive because negative and negative is going to give us positive 1. And positive 1, we know is greater or equal to 0. You know what I'm saying? So, you know, oh, for that case now it's done, man. We say for this function to be greater or equal to 0, this value of x must be less or equal to 0. Take any number which is either 0 less than 0 is going to work. At the end of the day, final is going to give us this. All function is greater than 0. So the first part is done, but I want to add something which is not part of the equation. You know what I'm saying? But I want to add. But the condition here, like I say, this x though, it should not be equal to 1 because if equal to 1, it's going to be a problem here. Now, let me add something here, man. We're done with the first question. I want to add something which is very important. They always ask you the line. Okay. Oh, it's going to come down. Don't worry about it. I'm going to erase this part I don't need. So the question that they ask every day, every time. Positive line of asymptote. Okay, so most of the time they're going to ask you the equation of a line of asymptote. No, equation, how did it ask me? I kind of forgot. But okay, this is what they're going to ask you. They're going to ask for a line. I just forget how to ask, but they're always going to ask you the equation of positive slope. Equation of positive slope, something like that. Or increasing function, decreasing function. On this, okay. So you look. Sometimes you can have a line which comes here, look. Let's say you have a straight line. Oh, negative line of symmetry. I remember now. Negative line of symmetry and positive line of symmetry. I'm going to write here. Positive line of symmetry, negative line of symmetry. So this question they always ask, positive line of symmetry, positive line of symmetry, positive line of symmetry. They ask this every day, positive line of symmetry. Positive line of symmetry. Or sometimes they ask for negative line of symmetry. Or you can say positive slope, line of positive slope. Or gradient. You know, slope is a gradient, it's the same thing. When they say gradient and slope is the same thing. Or they can say negative. Either positive or they can say what? Negative. Negative. So let's see how we're gonna find it. They ask this question every day, every time, baby. Easy, man. Let's get it, man. So now, so if they say negative line of symmetry, what is symmetry meaning? Symmetry, look. Let me give a good example. Okay, I'm just looking for something, right? Excuse me, just a minute, okay. If I got the book like this, now this is not a good example. Just a minute, guys. Please be patient with me for 1 minute. Okay, I got a pencil here. That's not a good example. Oh, yeah, I got it. Okay, so this is water bottle, okay? This is water bottle. So if you want to draw symmetry, symmetry is something which is going to divide in equal two parts. Okay, now let me cut here. Is it going to be 2 equal to parts? No, because if I cut 2 parts, the way how this is going to be look and this is going to be 2 different things. They're not going to look alike. But if I cut here, means I'm going to have 2 parts and they're going to look alike. So this is a line of symmetry. The line of symmetry is here for this case. Another example, this one, let's say. Give me line of symmetry. Line of symmetry, if I cut this, it's not line of symmetry because they're not going to look alike. This is going to have a mirror, this is going to have a keyboard. And the way you type. But if I cut like this, yeah, they're going to look alike. So you have a line of symmetry. So now, if you look at the hyperbola, where's the line of symmetry? Look, if I put a cut here, it's going to look alike. So we got 2 lines of symmetry. You know what I'm saying? If I cut here, it's going to look alike. Even if I'm going to cut here, look, it's going to look alike also. Even if I'm going to cut here, it's going to look alike. Oh, that's what we call it, well. This is positive. Whenever you have a line go that way, it's positive. So this is a positive line of symmetry. And this is a negative line of symmetry. So we gotta find them. Okay? So remember, these are asymptote, and your asymptote is intersect here. And the line of symmetry means it must cut there at the center so that 2 parts must look alike. So your asymptote, the intersect at this point here, what the value of x here? The value of x equal to 1 and the value of y equal to 0, where the asymptote they meet. You know what I'm saying? Now let's start with the positive line of symmetry. So positive line of symmetry, whenever they say positive line of symmetry means your gradient is positive. Oh, so my gradient equal to positive. But I say positive 1. Do not calculate and say, how did I get positive 1? How am I gonna work it out? It's a positive line of symmetry. When you say positive means it's 1, okay? When you say orange means it's 1 orange. It's not necessarily I say positive 1 orange. Oh, this is sanitizer. It's not necessarily I say 1 positive sanitizer. No, just a positive. Say positive sanitizer means it's 1. So whenever I say positive line of symmetry means it's positive 1. So I'm gonna say, okay, let me get positive line of symmetry. I'll say, okay, y equal to, equation of a line is mx plus c. So we know m equal to positive 1, so y equal to positive 1, 1x plus c. So how am I gonna get c? To get c, look, which point lie on this positive line of symmetry? The point where this asymptote they mirror, which is 1, 0. So that's a point which lies on both these asymptotes. So 1 and 0. So, so 1 and 0, but 1 and 0, it lies on this positive line of symmetry, even negative line of symmetry. Means I'm going to check y, I'm going to substitute here y equal to 0, equal to 1. What is the x? X equal to 1, because 1 times 1 plus c. So 1 times 1 is 1, it go over, it's going to be negative 1 equal to c. Oh, okay, negative 1 equal to c. So now finally, my positive line of symmetry is positive 1x. What is our c? C equal to negative 1. So that's a positive line of symmetry. Now, we want to get negative line of symmetry. This is very, very important, guys. They ask every year, every time. For negative line of symmetry, you do the same thing. So for negative line of symmetry, so you do the same thing. So y equal equation of a line, which is mx plus c. That is negative 1x plus c. You know what I'm saying? So now, this is a negative line. Negative line always go that way. So where is, which, do you have any coordinate we know? Oh yeah, easy, man. Which one? Right here, man. 1, 0. So 1, 0 is going to go right there, baby. So you're going to put y equal to 0. Negative 1. What is the x? X equal to 1 plus c. You know what I'm saying? So negative 1 times 1, negative 1. So 0 equal to negative 1 plus c. Oh, so go over is going to be positive 1. So our c equal to positive 1. So our c equal to positive 1. And then our negative line of symmetry is going to be what? To this equation here, negative 1x. Our c equal to positive 1. Oh, so this is the positive, is a negative line of symmetry. And you can see slope is negative, positive line of symmetry, plus slope is positive. So this must be negative 1, sorry. Apology. And you can see it make a lot of sense. Look, y is 1. Look, it's going to cut out. What is this? This is negative line of symmetry, right? Negative line of symmetry. Look, they say y-intercept equal to 1. You can see here, this is like a 1. You know what I'm saying? It's not drawn scale, so don't say like, oh, I don't know. If it was drawn scale, I think this was a 1 also, means it's supposed to cut at the same point, but I remember I didn't draw scale. So I think it's because even y-intercept of this graph, it was 1 if I'm not mistaken. Let me see, yeah, it was 1. So it has to cut like this, means this was the same point, common point. Okay, now let's count for this on positive line of symmetry. What the value of y? Negative 1. You can see here, look. This is going to cut at y. Y equal to negative 1. Man, listen, man. So that's how you do the phase equation of hyperbolic. But I'm going to do more equation. Stay in tune. Easy, man. So now I'm going to raise this one. We go to equation number 2. Calculus. You know what I'm saying? Let me just raise this. We're done with this party, man. Okay, cool. Now let's go for calculus here. Quick. Easy, 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 man. It's a non-river prime. I hate your corona, man. You know, you're going to go away this time. We're going to do a little math until we take it away. Let's go. Feel me, 100, man. Man, listen, the aim here is to get 100, man. When I aim, if you know you want to get like 40, 50%, please get out of here. We don't want you. You know what I'm saying? This group is for the people who are hungry, man. Get 100%, only 100%. So if you're like, oh, I just want to get only 60, it's fine for me. Please don't watch my video, okay? Only for the hungry people, babe. Let's go, man. People who are hungry, man. Get all those corona, COVID-19, eat them all. Let's go. Let's go. Easy. Okay, cool. Now let's go, man. So now the first part I think I'm done already, so let's just make some space because we might need some space too on top here. Let me try to go quick a little bit. Okay. Okay, cool, let's go, guys. Cool, no problem. Let's go, let's go, let's go. Let me draw the whiteboard. Okay, so first and foremost, calculus is the easiest topic, you know what I'm saying? So how we derivate? If somebody give you, let's say, y squared equal to x cubed. Let's say this is negative 3. Let's say find derivative. So to derivate is easy. Come on, man. What you do, you see this number here? Which number is here at the back? Is 1, okay? So you take this power to the back. So when you take, you must multiply. Say 2 times the number which is here. 2 times 1 equal to 2. And then you drop this number the way how it is, which is y. And then take this power minus 1. Which power? 2. 2 minus 1 equal to 1. We have done already derivate. Let me say it again. Take 2 to the back and then multiply by the number here. So it's going to be 2 times 1 equal to 1. You drop your number y, the letter, and then take the power minus 1 equal to 1. So which one did you do here? What did you derivate? You derivate y, so you must give it respect. Every time you derivate, you must give respect. Which respect? Y, so you must say dy. Because of a y. Now we come and do the same game. Take the power, which is 3, the exponential. 3 times negative 3 equal to negative 9. And you drop your x, take the power minus 1. 3 minus 1 equal to 2. So what did you differentiate here? Differentiate x, so you must give respect. With all respect. So with all respect means you differentiate x, you say dx. We're done already. So remember you want to get dy dx. So since you want to get dy dx, means I don't need it here. So I'll say divide by dx because you want to get dy over dx. So divide by dx and divide by dx. Listen to this constant, you know what I'm saying? So say, oh, okay. So dy over dx equal to negative 9x squared. And remember here we have it 2y. Y power 1 is y. So we don't need this 2y. Divided by 2y, divided by 2y. So we can get dy dx. Divided by 2y and here divided by 2y. This and this cancel. So dy dx equal to negative 9x squared over 2y. But remember, in equation, when you finish, you don't need y here. You just need everything must be in x. So remember, y squared equal to negative 3x squared, which was given from the equation. So since I want to get only y, what I'm going to do, I'm going to square it, and I'm going to square. Y and y go, so y equal to negative 3x square. Oh, so I'm going to take this one right there, baby, and it's done. So say, oh, so this meaning negative 9x squared over 2 is just a 2. I'm not going to write y anymore. I'm going to write, instead of y, I'm going to replace it with this, y equal to this. So say square root of negative 3x squared. Done. So dy dx equal to this. That's how you derive it. Come on, man. That hard? No, it's not hard. Easy, man. So now, I'll just drink some water. Excuse me. Excuse me. So you're done already. That's how you derive it. Let me give 2 examples and then we go. We go to the question. Okay, so now, somebody gives something like this. Let's say, for example, okay, somebody gives stuff like this, for example. If somebody give you, let's say, y square equal to, let's say, negative 3y square equal to, okay, reciprocate. I hope you know how to reciprocate. Some people, they don't know how to reciprocate. It's easy. Before we go to the question, if somebody give you, let's say, 3x power 8. Okay, to reciprocate is easy. Means, you see, don't worry about number. Take this number next to number. This letter means the variable. It has to come under the number. So it's going to become over. Take exactly right under here. See this, the one cycle? But you see this negative is going to become positive. You know what I'm saying? So that's how you reciprocate. You can take out 2. So if somebody give me 80 or 18 over. So if I want to reciprocate, you cannot reciprocate when it has a root. It must be in power. So this, let me say 18 over. So first and foremost, I'm going to remove this. So if I remove this, if this say x 3, remember this is like square. Because look, like x power 3. But a number here means it's, okay. This is very, very important. Show you people, okay, look. Excuse me, let me raise in something quick. If somebody give you this, y, which number is here? Here is 2 over 1. Even if they didn't write, means 2 over 1. So this time you say y, and then flip this, it's like 1 over 2. Remember that. So if somebody give me k, 3, means this is 3 over 1. Even if they don't write, because when you say 3, it means it's 3 over 1. When you say 5, it means 5 over 1. And then this is going to be k, and then you flip this number up and down. It's going to be. So if somebody give me this, the last one, right? Let's say this is t, and they give me m. So what does that mean? This is like m over 1. So this is like, say, t, and then 1 over m. That's all. You know what I'm saying? That's how you reciprocate back and forth. So even if somebody give me, let's say, okay, 3, 4 over 5. So if I want to put in root, I'm going to say, oh, I'm going to write my number 3, and then I'll flip this. It's going to be what? 5 over 4. So now we come here. You know what I'm saying? If somebody reciprocate this means first it must be power, and then to reciprocate is which number is here means there's a 1 here. So I'll say this is 1 over, and then I'll take everything with the power to the bottom. It's going to be t, but the only thing you change the sign here. If it's positive, become negative, the negative become positive. So there's going to be negative 1 over, and that's how you reciprocate. So now, first and foremost, before you derivate, make sure you put in power, baby. You know what I'm saying? You must be in power, man. Easy, man. Don't put it with a root. So before you derivate, put everything in power. So what I'm going to do here, let's say equal to, let's say 3, I'm going to say 80, and they give me x, let's say 3. So what I'm going to say, like I say, if there's no number here, means it must be 3 over 1. So this is going to be negative 3y squared equal to negative 80. Okay, negative 80. And this one here is going to be x. I have to flip it. This is going to be 1 over 3. So now, do not derivate when it's at the denominator. You must take it to the top, baby. So it means I must reciprocate this to the top. So this is going to be negative 3y squared. When you write left and right. Don't write only one side. You know my rule, I say when you write, don't write like one side. Write them both because you don't want to lose marks. You want to get all the marks. When I was face here, I told you every day I go 100%. You know what I'm saying for my face here. So take this one up. So say this is going to be negative 8. See this is going to go to the top. When you go to the top, remember this is positive, it's going to become negative. So it's going to be 80x negative 1 over 3. Okay, so that's what you got now. So now we can derivate when it's in this form. So when you want to derivate, you must take the bottom to the top if it's in root. So first it went to the power, and then I take to the top, and then after that I can derivate, because you see it's going to be easier for this to come back. So now let's derivate. 2 times going to be negative 6. Negative 6. And then drop my y. 2 minus 1 equal to 1. What did I differentiate? You differentiate y, give respect dy. Equal. Now we come here. Take negative 1 over 3 times negative 8. Take your calculator, multiply. Negative 1 over 8 times negative 1 over 1 over 3 is going to give what? 3 over 8. But I positive because negative multiply 8 times this 2. Put in the calculator, it's going to give 8 over 3. Now write your x. Take negative 1 over 3 minus 1. Take your calculator, plug it in. But me, I don't use a calculator for this because it's like -1/3 minus 1. But in my trick, I don't say -1. 1, look, I'm going to say 3/3 in my head. I'll say, okay, this going to be what? It's like 1 is like 3/3. But put in your head, right? You do it in your head. It's okay because it's going to be equal to 1. So now, the denominator is going to be the same thing. -1 minus -3, -4. Any number, if I got 1 over, let's say 2/5 minus 7, minus 1. How am I going to say? I would say 7/7. Because 1 is 7. No, excuse me. Minus 1. Look, this is 5. So here say 5/5 because you want to make the denominator equal to 7. So this is like 1. So you have to look at this and then create a number which is going to be same without 1 equal to 1. And this is going to be, I write the same thing, 5, -2 minus -5 with -7. So same here. I'm going to have to take -1/3 minus 1, which is going to be, okay, so it's going to be 3/3. It's like minus 1. 1 is like 3/3. You know what I'm saying? Because I want the denominator to be the same. So in your head now, don't do see all this dirty stuff. So you do say, okay, the denominator is going to be 3. Now, -1 minus -4. Oh, so this is going to be -4/3. So, and when you differentiate, you must do both sides, left and right. Okay, cool. So what did you differentiate here? X. So you must give respect to the x. I'm going to erase here. So for that case now, I'm going to say, oh, we're done, man. So on the left, remember, I want to divide dx. So I'm going to divide it by dx, and I'm going to divide it by dx. Okay? I hope you can see that, man. Okay, so now I'm going to write again, just in case for some people didn't see, -1 dy equal to 3/80 after taking back, and then x, and then we say what? 1/3 minus 1 equal -4/3, -4/3. But I want to differentiate x, so give respect dx. So remember, you want to get dy dx all the time. So I'm going to get it divide by dx throughout, divide by dx throughout. Listen, let's go. So I'm going to have -6y dy over dx equal to 3/80. Okay, another thing, see this number here is on top. So you've done already, but since this number is negative, you don't want to have a final answer as negative number. So I'm going to reciprocate, means I'll take to the bottom.